In this video, we'll discuss choosing an electrical storage service voltage for a sailboat. Which is better, 12, 24, or 48 volts? First, we will discuss choosing and creating an electrical system from scratch, then options for upgrading a boat with 12-volt equipment already installed. Welcome to the channel, Paradise Workshop. The advantages and disadvantages will be considered from the following aspects: safety, in terms of electric shock; compatibility with yacht equipment; network design limitations and network construction costs. A 12-volt network is the most common electrical network on small to medium-sized sailboats. Most often, 12 volts is the default electrical network when you buy a brand new boat from a shipyard. Safety, an electrical injury. The main rule is, current will kill, but some voltage is required to flow that current in the body, breaking the human body's resistance. Enough power is required to pass in the human body for proper electric shock. DC current 160 to 300 milliamps is enough for respiratory block. The National Institute for Occupational Safety and Health states, under dry conditions, the resistance offered by the human body may be as high as 100,000 ohms. Wet or broken skin may drop the body's resistance to 1,000 ohms. But if the skin, which is a protective barrier, is significantly damaged, then the inner resistance of a human body can be 300 to 500 ohms only. Let's figure out what current theoretically can be delivered in a 12-volt system. In the case of LiFePO batteries, we can reach the voltage of 14.6 volts and current 49 milliamps. It is safe from any point of view. Compatibility with boat equipment. 12-volt equipment, manufactured for boats, is the most widely available, but some high-performance equipment may be missing from manufacturers' lineups. Compatible with all types of drop-in LiFePO 12-volt batteries. Only 4 cells are needed for self-assembly. Cost of building a 12-volt network. Low voltage means high current, and high current has some disadvantages. System design limitations. Often, it is impossible to use one centralized BMS because of the current limitation of the contactor relay, for example. It is more difficult to find wires with a larger cross-section. It is more difficult to find circuit breakers and high-rated fuses. Large voltage losses in wires. The power of devices, inverters for example, is usually limited to 3000 volt-ampere, and to connect more consumers, it is necessary to use several devices in parallel or independently. Some high-performance equipment is not available at 12-volt ratings. High cost of system components. Circuit breakers, fuses, and switches with high current ratings are much more expensive. Wires and busbars with a larger cross-section are more expensive. Often, an active 12-volt equipment is more expensive. The 12-volt allows us to organize the next systems. Basic system, up to 500 ampere and up to 6 kilowatts of power. Extended, up to 1000 ampere and up to 12 kilowatts of power. 24-volt system. Is 24 volts a safe voltage? In the case of LiFePO batteries, voltage can be 29.2 volts. Potentially, the maximum current is 98 milliamps. Yes, it is still less than 160 milliamps and safe. Compatibility with boat equipment. 24-volt equipment manufactured for boats is also widely available for sale. Lamps, water makers, toilets, winches, pumps, and all the rest, everything is available for a 24-volt system. High-consumption equipment is also available. Serial connection of drop-in LiFePO batteries for organizing 24-volt is not available for all manufactured batteries, but finding the right one is not a big problem. For the self-assembly of LiFePO batteries, we need 8 cells. Cost of building a 24-volt system. The current is 2 times less than in a 12-volt network, and the cross-section of wires, the ratings of circuit breakers, fuses, and contactor relays are 2 times less. All this significantly affects the cost of installation. Less loss in conductors. The power of devices, inverters for example, is usually limited to 5,000 volt-ampere. The 24-volt system allows us to organize the next electrical system on boats. Basic, up to 500 amperes and up to 12 kilowatts. Extended, up to 1,000 amperes and up to 24 kilowatts. 48-volt system. Is 48 volts a safe voltage? In the case of LFP batteries, voltage can reach 58.4 volts and current potentially is 195 milliamps. So, 195 milliamps is more than 160 milliamps. This voltage is potentially dangerous under abnormal conditions, but is reasonably safe for most people under normal conditions. What do abnormal conditions mean? A boat can be a set of abnormal conditions: open wires, sweaty body, hot and wet, vibrations, and possibly repairing process at storm at sea with skin damage. So, if you plan to build the 48-volt system, it is better to locate it in a separate waterproof room or cabinet and clearly understand its potential danger. That's why the 48-volt system normally is not used on leisure boats. Compatibility with boat equipment. 48-volt equipment, manufactured for boats, is not as common as 12 and 24-volt equipment. You simply won't find some parts of the equipment. Not all drop-in LFP 12-volt batteries can be connected in series to organize a 48-volt battery. 16 cells are required for self-assembly. It is impossible to connect most modern solar panels in parallel because in case of MPPT, the nominal PV voltage should be at least 5 volts higher than the battery voltage, but in reality, 37 to 44 volts as the nominal PV voltage of a modern solar panel 300 or 400 watts is less than the battery voltage in case of 48-volt system. Cost of building 48-volt system. A current is 4 times less than in a 12-volt network, and the cross-section of wires and the ratings of circuit breakers, fuses, and contactor relays are 4 times less. All this has a very significant impact on the cost of installation. Less loss in conductors. The power of devices, inverters for example, is already up to 15,000 volt-ampere. 48 volts allows us to organize the next electrical system on a boat. Basic, up to 500 amperes and up to 24 kilowatts. Extended, up to 1,000 amperes and up to 48 kilowatts. So, what is the best? Based on the set of characteristics, 24 volts is the optimal system for small and medium sailing boats with developed infrastructure. The network is safe from the electric shock point of view. No design limitations, and all boat equipment is available on the market. The installation cost is significantly lower than a 12-volt network installation. Even basic installation provides power to consumers within 12 kilowatts, which is comparable to small city apartments. How to get an optimal system? If we buy a new boat from a shipyard, it is optimal to order a 24-volt electrical system. If we buy an old boat with the desire to build a high-performance electrical network, then it is also optimal to build a 24-volt system from scratch. If we buy a boat with modern and normally working 12-volt equipment, marine toilets, windlass, electrical winches, and want to convert the system to 24-volt, then we are faced with the question of what to do with the installed 12-volt devices. There are several options, but they are all inconvenient and expensive. The first option is to replace 12-volt equipment with 24-volt equipment, expensive but reliable, and old equipment can be sold. The second option is to replace only electric motors with compatible 24-volt ones. If the manufacturer has such an option, Sometimes this can be cheaper than option 1 and also reliable. And the third option is to use DC-DC converters 24 to 12 volts to connect old equipment. The option is not cheap and unreliable, taking into consideration the fact that critical active elements of the boat require fault tolerance, duplication or redundancy. For example, for 24 to 12 volt windlass 1500 watts conversion, we may need 2 step-down converters of 150 amps each, costing over $500 each. At the same time, additional active equipment will take up a lot of space and may not work for long in a marine environment. Bad option in our opinion. That's all for today. Stay smart and safe. Subscribe to the channel. Thank you and goodbye.